Hi guys, today we're going to talk about how to solve for missing side links. So for this ed puzzle you should have this page, and you should also have a blank half page that's blue this time. It might be a different color for you next year. Okay, so you're going to go ahead and fold this blue half page in half. And then you're going to cut 3 flaps. So essentially, like, we want it to line up with these examples here. So, just kind of lift it up here. And you're going to cut one here. And then kind of make sure it lines up with the other example down here at the bottom. Maybe like right here. You're just trying to make sure you've got 3 flaps that kind of, because these first 3 examples here are meant to match up with the outsides of these flaps. Okay, now, on the outside of this, so now you've got your 3 little flaps, you're going to write SOHCAHTOA. Alright, and I wrote mine pretty. You can write it however you want, but it's so, and then it's ka, and then it's toa. And from yesterday, you should pretty much remember that this was a way to remember about the fractions we're writing for sine and cosine and tangent. Okay? So for so, that really stands for the word sine, S-I-N-E. And really we're talking about, like, we might see sine of theta. Remember, theta is that crazy looking 0 with a line through it. And then for cosine, that's the ka, so it's cosine, and that's COS and then theta. Okay? And lastly, for tangent, that's the T, so it's tangent, and that's TAN of theta. Okay? And what we're going to do on the inside of this is we're just going to kind of draw triangles to help us remember, give us like a little bit more of a heads up, okay? You should probably be pretty good at this by now, but it's okay if you're not. So let's go ahead and on this side we're going to draw a right triangle. We're going to label theta up here. And then we're going to figure out what our sides are. So this side is opposite, this side is adjacent, and this side is hypotenuse. Okay? And remembering on the front, sine of theta equals, and it's opposite over hypotenuse. Opposite over hypotenuse. So we're talking about this opposite side over here, over this hypotenuse over here. So we've got sine is opposite over hypotenuse. So, okay. And do the same thing on the next one. And just draw yourself a right triangle. Same thing, we're going to call this theta, so this is still adjacent, this is opposite, this is hypotenuse. Now we're talking about cosine of theta. Remember that one is ka, so it's adjacent over hypotenuse. So it's adjacent, cosine is ka, adjacent over hypotenuse. Lastly, we're going to have our toa. So we're going to draw our right triangle. And still have theta up here in the top corner, so we still have adjacent, opposite, and hypotenuse. But toa is tangent of theta, and that's going to be opposite over adjacent. So we're going to use our opposite over our adjacent, and that stands for toa. Okay. Alright, so I just wanted to have this foldable here to help us remember all of our rules in case we forget, but also so they'll be right next to our examples that we're going to do. I'm going to complete 6 examples where we are solving for the missing sides, and then I'll explain how to glue them into your notebook. Alright, so let's start with example. This is not example 1, it's just example. I should have labeled them as numbers. Okay, so it tells us our angle right here, number 61 degrees, right here. Okay, so that means this is our theta. Okay, this is the angle of interest. So that means we need to label the rest of this triangle. So opposite our theta is going to be 24. X is our hypotenuse, and this side is adjacent. Okay? And so instead of writing theta in our in our equations and our fractions, instead of writing this theta right here, we're going to put this 61 degrees. Okay? So now we just have to decide which 2 things did they give us. So I'm going to go ahead and highlight the 2 things that they gave us. They gave us hypotenuse and they gave us opposite. Right? They gave us x and they gave us 24. So which one of those 3 different things uses OH? So it might be easiest to look at the outside, and that's sine. Sine uses O and H. So we're going to say sine of 61 equals opposite over hypotenuse, which is 24 over x. Does that make sense? Just sine of 61. We picked sine because it was opposite and hypotenuse, and it equals that fraction 24 over x. So I'm going to write it so it's all one thing. So sine of 61 equals 24 over x. Now the best way to solve this is to go ahead and cross multiply. So what I'm going to do is I'm going to put sine of 61 over 1, and then I'm going to cross multiply to get my answer. Okay? Now this is probably one of the harder examples first, and that's okay. So we have sine of 61 times x. So we're going to write x parentheses sine 61 equals, and then we have 1 times 24, which is just 24. Cross multiply. If we want to get x all alone, we're going to have to divide by this sine of 61. Okay? Remember, if I typed sine of 61 on my calculator, I'm going to get a decimal. So just because there are letters right here, that does not mean that this is a variable. Okay? Sine of 61 is actually a number, but I don't want to get rid of this word until the very end of my problem. So I'm going to divide by sine of 61 on both sides. Okay? Which means I'm really just dividing by this decimal here. Okay? So I'm going to say this is 24 because it's on top. So we'll say, and this cancels out. Sine of 61 cancels out. So it's 24 divided by sine of 61, and put parentheses. So when you type it on your calculator, it looks like this. And when you push enter, you're going to get a long decimal. So we're going to say x is about, and we're going to round to the nearest hundredth because everybody needs to know about how to round money. So we're going to practice rounding as if it were money that we were talking about. So the nearest hundredth. So there's 100 pennies, that's how you can remember. It's 100th is 2 places in. So it's 44, and there's a 0 after it, so that means it stays a 44. So it's 27.44. So what we have just found is this side length x. Okay, we've just found this side length x. Alright, let's look at number 2. So number 2, or the second one on this page, let's label what we have. So theta is this 27, that's theta, and across from it, that's going to be opposite. Touching it, that's going to be adjacent. And this is across from the right angle, so that's going to be our hypotenuse. So what letters do I have? Well, they gave me H, they gave me 19 as H, and they gave me X for letter A. They didn't give me anything for O, so I'm not going to use O. Okay, so the only letters I'm using are adjacent and hypotenuse. So which one of these three matches that? Cosine, because I have adjacent and hypotenuse. Okay, so we're going to say, we'll set this up by saying cosine, and instead of theta, we're going to say 27 equals, and then we're going to say adjacent over hypotenuse. So that's going to be x for adjacent and 19 for hypotenuse. Okay? Then we're going to make a cross product to solve it. So we'll put cosine over 1, and we'll cross multiply. This cross product is just x. This cross product is 19 times cosine of 27. So this problem is way easier to solve because I already have x all alone, and all I have to do is multiply that on my calculator. So I take out my handy dandy TI-84 Plus graphing calculator, and I type in 19 cosine of 27, and I get my answer. Now remember, we're rounding for money, so we're going to look at this 2. The number right after the 2 is a 9, so that means this actually turns into a 3. So we say x is about 16.93. Remember, that is solving for our side length, so 16 makes sense because I have a 19 here. I shouldn't get 169, that wouldn't make any sense. Alright, last one on this side. We're going to go ahead and say this is theta, so across from theta is the opposite. 13 is adjacent, and here is my hypotenuse. So which ones did they give us? They gave us x, which is opposite, and 13, which is adjacent. So if we look at our 3, we've got opposite and adjacent on this one. So we're going to do opposite over adjacent. Tangent. Remember, we write tangent. Instead of putting theta, we put 52. And then we put opposite, which is x, over adjacent, which is 13. Next step is to cross multiply. Put the tangent over 1, and then cross multiply. This is x times 1, which is x. And this is tangent 52 times 13. I always put that 13 in front of tangent 52. And now it says x all by itself, so I don't have to do any dividing. So I'm just going to use my calculator. 13 tangent 52. And I get this number. We're going to look at the 3 because we're talking about money. Not really, but we're preparing ourselves to understand for money later. So 3, that's a hundredths place. Next to it is a 9, that's the thousandths place. So that means that that 3 turns into a 4. So this would be about 16.64. Does that number make sense? Is it close to the other number for sides on my paper? Sure is. There's a 13 there. That's pretty close to 16. Okay. Alright. These 3 examples are kind of mixed up. We're not meant to put these examples in order of sine, cosine, and tangent. So let's decide which one we're going to do, and then we'll move on. So 37 degrees, so that's my theta. Opposite theta is 10. Adjacent theta is A, and we've got H. So which letters did they give us here? I'm just going to pick a color. 10 for opposite, X for A. Which one of these 3 on our paper here do we have that goes O and A? We want the one that says O and A. This one's O and H. This one's A and H. This one's O and A. So this is tangent for this example here. Tangent. And it's going to be tangent of, and you put, instead of theta, you put your 37 degrees. And then what's O? That's 10. A is X. Now we're going to cross multiply. 10 times 1 is 10. And on the other side, tangent 37 times X. Put the X first. Okay. if I want to get x all alone, I'm going to have to divide by this tangent of 37. So x is equal to 10 divided by tangent of 37. And now I'm going to type that into my calculator. 10 divided by tangent of 37. It's about 13.2. Does it stay 7 or does it turn into an 8? Well, the next number is 0, so it's going to stay a 7. Is 13 close to my other side on my triangle? Yes, it is. I don't want to get too crazy with our numbers, so we want to make sure they're kind of close together. Reasonable, anyway. Alright, next example. Opposite, that's this side. Adjacent, that's this side. Hypotenuse, that's this side. Highlight the ones that gave us letters. We've got hypotenuse and adjacent. So which one of these three on here has A and H? Not sine, it's cosine. Cosine has A and H. So cosine is A over H. So A is going to be cosine. Instead of theta, we write 25. A is 12. H is x. Cross multiply. Well, it means we put this one over 1. When we cross multiply, we get 12 equals x times cosine of 25. Okay? Remember, I always put the number in front of this phrase. This phrase always stays together. So now to get x all alone, I'm going to divide by cosine of 25. So it's x equals 12 divided by cosine of 25. That's 13.24. It's going to stay a 4 because the number after it is a 0. Okay. Last example. This is my angle. Opposite is going to be this one. Adjacent is this one. And hypotenuse is this one. Let's highlight what we see. We see that we've got 8 goes with opposite. X goes with hypotenuse. So we've got opposite and hypotenuse. Which one of these has opposite and hypotenuse? Sine has opposite and hypotenuse. So this is sine of 7. Instead of theta, we write 7. Equals, opposite is 8. Hypotenuse is x. We're going to cross multiply. So this is 8 equals x times sine of 7. To get x all alone, I'm going to divide by sine of 7. So this is x equals 8 divided by sine of 7. May or may not be a decimal. We'll see. Probably is. 8 divided by sine of 7. That's about 65.64 because the number after it is a regular 4. So 65.64. Okay, so now we are going to glue this into our spiral. So you'll need to have your spiral. So it goes after your calculator page. So it's going to go here. So what you're going to do is you will glue the blue page. Actually, you could probably just put them together like this. It'd probably be kind of cool. Fold this one in half. And then put this one right here if you wanted to, like on top of it, if you wanted to save paper and have kind of a double foldable. But I had intended for it to be like my example next to it so that you could see it all in one line. That's awesome. I didn't show you what I meant. Okay, so I am going to cut it in half. because I had it originally intended for my examples for each one of those on this first page to be right next to each other. Okay, so if you see my example for sine, my example for cosine, and then I had an example for tangent. So I had one of each type next to each other. So glue those together on one page, and then on the next page, glue in your second set of examples. Okay? Thank you so much for watching, and have a wonderful day.